Hello everyone, today we'll be taking a look at twosome, probably the most famous Leetcode question of all time. We'll be going over an introduction to complexities and the optimized solution for this problem. So, given an array of integers nums and an integer target, return the indices of two numbers such that they add up to target. So that's where the name twosome comes from, I guess. You may assume that each input would have exactly one solution and you may not use the same element twice. So same element, this means that I guess if you have 1, 1 and your target is 2, then you can use each one separately, but you just can't use this one twice. So that's what that means by the same element twice. You can return the answer in any order. Right, so we're given this example 2, 7, 11, 15 with a target of 9. Just by looking at it, we can kind of tell that 2 and 7 are going to be the answers because 2 plus 7 equal 9. So our outputs are going to be 0, 1, the indices of these two numbers. So we'll take a look at what's actually happening here, and we'll take a look at probably the most intuitive way to approach this problem. This is going to be the brute force way. This is probably what most beginners are going to be doing, are going to be thinking when they look at this problem. Just instinctively, we know that let's say we do a for loop. Most people trying this have seen for loops before. You can set this index equal to I, and now at this element, we're going to be checking if, so we have target equals 9. We're going to be checking if any of these other numbers will add with this number to get it equal to 9. So 2 plus 7, obviously that equals 9, but for the sake of example, let's assume that it doesn't. 2 plus 11, 2 plus 15, and if none of these equal the target, then we would increment I. Then we would do another for loop. So let's say that we have j, this second element, or this second, we'll say j is the starting index of the second for loop. Then we can increment I, and then j would just be I plus 1 because we're checking every other number. Then at this new index 7, we're checking the rest. We'll check 7 plus 11, we'll check 7 plus 15, and if none of those work, then we'll increment I again. So I will now be over here, and j will be I plus 1, it'll be over here, and for our final example, we'll do 11 plus 15, and if the target was something like 26, then we would be able to return I and j. So while this may seem intuitive, and while this may just seem like the correct answer, this is actually the answer that I put and just moved on, there's actually a few reasons why this is not a good answer. The primary one being complexity, sorry. So complexity is a concept in data structures and algorithms that you may have heard of, and it determines the optimalness of an algorithm. So the complexity is separated into both time and space complexity, and I'll give you a very brief rundown of each one. So time complexity is how long it takes for an algorithm if the given data set was very large. Let's say it was n length instead of just the 4 integers that we were given. So if we have this length n, right, if the data set is, let's say, 5 million integers, then obviously it wouldn't matter what our algorithm looked like. If we're doing 2 for loops, we have 2 for loops embedded within each other, then this first for loop is going to check 5 million different indices, and this second for loop is going to check for the first element. It's going to check 4,999,999. It'll check a lot, and pretty much we can simplify this to being O of n times n, or O of n squared. This is quadratic time. This is typically bad. This is not a time complexity that you're going to want when you're solving these Leetcode problems. But yeah, this is quadratic time. The best time complexity is constant time, where no matter how big the data set is, you'll have a constant time. It won't really matter. You're still just doing the one thing. If you have one for loop, for example, though, then you would increase to linear time, meaning that as this 5 million, this n number gets bigger, then so will that for loop, because obviously the for loop is going to take as much time as the array is long. But if you have these two for loops embedded within each other, then we have this sort of quadratic time. So this time complexity is going to increase n times, pretty much. Now, for space complexity, the good thing about this brute force solution is that it has a very good space complexity. Space complexity is similar to time, but it considers the space of any new like arrays, objects, any new data structures that you create. So let's say you created a new array that was a copy of nums. Then this new array would have length n, and that would be linear space, because if n was 5 million long, then array would be 5 million long. let's say you created a new array for each instance of this for loop. You create a new array here and you create a new array here. That would be n squared space. You would create, you would create n times n arrays essentially. But for this case, you're just iterating through the for loops and checking for valid conditions. So you're not actually creating any new variables, which means that the space complexity for this one is just O of n. It's constant space, which is quite good. But this O of n squared is really dragging us down. So we want to consider something different for the optimized solution. So let's take a look at what this optimized solution is going to be finally. So the optimized solution, I have an extra I in there. The optimized solution is going to incorporate something that's called a hash map. And a hash map is something that you guys have probably heard about before if you've watched any videos on data structures and algorithms. But in this case, we'll be implementing it in quite a simple way. We'll just be using an object where the key value pairs, each key value pair is going to be an element and the index that element's at. And this is actually much more simple than you might think it is. So we'll do a for loop, and then for each element, we're going to have this map at that element equal to index. And that's it. That's all we'll do. So we'll create this hash map, and after doing this whole for loop, then our map element is going to look like we have these key value pairs. 2 is going to be at index 0, 7 is going to be at index 1, etc. So I'll write that a little bit cleaner here. So we'll have the case 2, and I believe it was 7, 11, 15 with a target of 9. Then after doing this for loop, we'll have this map with the key value pairs 2 of 0, 7, 1, 11, 2, and 15, 3. So this is what our map is going to look like. Now, what can we do with this map? We're going to want to figure out for each element in this array, is there another element that will make this, that when added to this element will equal this target? So what we can do is check if the target minus the element at index I exists in the hash map, right? So what we can do is we can do another for loop, and then for each element in this array, for each element, does map contain target minus the element? And we'll just say I is equal to the element, not the actual index. So if this exists, if it's not equal to undefined, then we know we have an answer. So we can then just return what this map target minus I is, because remember that's the index, and we can also return the actual index at I. So let's take a look at the code and see if that helps piece some things together. All right, now let's take a look at the code. So we'll be coding this in JavaScript. And the very first thing we're going to want to do is set solution equal to an empty array. This is going to be what we're going to change and then return at the very end. And we're also going to let a map, this is our hash map, equal to just an empty object. And now we're going to want to fill this hash map up with element index as key value pairs. So then what we can do here is num.forEach, and we'll take the num and the index, and what we'll do is we'll set the map at that num equal to the index. So now at this point, our hash map contains each element index as key value pairs. So now we'll go through our second for loop. We'll let I equal 0, I is less than num.length and I++. We're going to iterate through this whole thing again, and now we're going to let, I guess, the pair that we want, let desired pair equal to the target minus num's I. So if we're at 2 and target is 9, then our desired pair obviously is 7. Now we're going to check if the map of the desired pair exists. So if it doesn't equal undefined, and there's also one more thing we have to check. We have to check that it's not a duplicate. So map desired pair does not equal I. If they're both at the same index, then that kind of defeats the whole purpose. We would have a duplicate, and that's not what we want. Then at this point, we would push map at the desired pair. So we would, that's the index of the desired pair number, and we would also just push I. And after this, we can just immediately return Sol because we don't want to update updated anymore. And if we submit this, sorry, forgot that you had to be logged in. If we submit this, then yep, success, this works, and yep, that's how it's done.